Hello, my dear students. This is the second presentation of chapter Force and Laws of Motion. Your today's topic is Laws of Motion. Newton's laws of motion. As you all know that Newton's gave us three laws. That is Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. Newton studied the ideas of Galileo and gave the three laws of motion. Newton's first law of motion. Any object remains in a state of rest or in uniform motion along a straight line until it is compelled to change the state by applying external force. It means that Newton stated in first law of motion that is every body continuous in a state of rest or uniform motion in a straight line. एक बॉडी कंटिन्यूसली रेस्ट पे रहेगी या यूनिफॉर्म मोशन में ही रहेगी अनलेस कंपेल्ड बाय नेट एक्सटर्नल फोर्स टू चेंज दैट स्टेट तब तक जब तक ना आप उस पर कोई एक्सटर्नल फोर्स अप्लाई करोगे उसका स्टेट चेंज करने के लिए फर्स्ट स्टेट उसका रेस्ट हो या यूनिफॉर्म मोशन हो आप उस पर जब फोर्स अप्लाई करते हो तो वो अपनी जगह से हिलता है या रेस्ट पे आता है तो ये आपको न्यूटन फर्स्ट लॉ में कहता है एवरी बॉडी कंटिन्यूअस इन इट स्टेट ऑफ रेस्ट every body continuous in its state of uniform motion in a straight line unless compelled by net external force to change that state. This is the first statement of Newton's first law. For example, when we push a ball on the floor, it comes to rest after some time. The ball does not come to rest by itself. It comes to rest due to the air resistance and the force of friction between the floor and the ball. ये आपको कहता है ये वाली एग्जाम्पल आपको बताता है जब आप किसी फ्लोर पे एक बॉल को छोड़ते हो ऑटोमेटिकली बॉल जो है किसी जगह पे रेस्ट पे आता है और उस टाइम उसको कौन फोर्स लगाता है फोर्स ऑफ फ्रिक्शन फोर्स ऑफ फ्रिक्शन उस बॉल को रोकता है एयर रेजिस्टेंस की वजह से वो बॉल जो है रुक जाती है दिस इज़ द एग्जाम्पल फर्स्ट एग्जाम्पल सो नेक्स्ट इज़ द explanation. A person standing in a moving bus falls forward if driver applies brakes suddenly. This happens because when bus is moving, the person standing in it also in motion along with bus. But when driver applies the brakes, the speed of bus decreases suddenly or bus comes in a state of rest suddenly. In this condition, the legs of the person which are in contact with the bus comes in rest while the rest part of his body have tendency to remain in motion. Because of this person falls forward if he is not alert. So these are the explanation of Newton's first law of motion. And the next slide is that is momentum. Momentum is the power of motion of an object. It means it is the quantity of motion contained in a body. एक बॉडी में कितना क्वांटिटी से मोशन भरा हुआ है दैट इज़ द मोमेंटम ऑफ अ बॉडी सपोज वी हैव अ टू बॉल्स ए एंड बी हमारे पास दो बॉल्स हैं ए एंड बी द बॉल ए इज़ हैवियर देन बॉल बी the mass of ball A is greater than the mass of ball A because the ball A is heavier and the ball B is lighter. Both the balls are moving with same velocity लेकिन इन दोनों balls की velocity जो है वो same है. Then the force needed to stop heavier ball is more than the force needed to stop the lighter ball because the ball A is heavier. This shows that heavier balls has more quantity of motion than a lighter ball. It means linear momentum of a body is directly proportional to the mass of the body. इसका मतलब है जो लीनियर मोमेंटम होता है एक बॉडी का वो डिपेंड करता है एक बॉडी के मास पे. That is the linear momentum. So linear momentum of a body is the product of mass and velocity of the body. P is equal to mv. Momentum is denoted by the letter P, mass is denoted by the letter m, and velocity is denoted by the letter v. So P is equal to mv. So these are the explanations of momentum. A person gets injured in the case of hitting by a moving object such as stone, pebbles or anything because of momentum of the object. क्योंकि एक पत्थर से अगर आप किसी पत्थर से किसी इंसान को मारते हो तो उसको लगती है. इट मीन्स जो उस बॉडी में क्या है, मोमेंटम. Next explanation. Even a small bullet is able to kill a person when it is fired from a gun because of its momentum due to a greater velocity. So momentum, linear momentum is the product of mass and velocity. And the SI unit of the momentum is kilogram meter per second. The SI unit of the mass is kilogram. The SI unit of the velocity is meter per second. That's why the SI unit of momentum is kilogram meter per second. Linear momentum is a scalar quantity whose direction is same as that of the velocity. Momentum of an which is in the state of rest. अगर आपका ऑब्जेक्ट जो है अब रेस्ट पे है, object is in rest, its velocity is equal to 0, so momentum is equal to 0. So the momentum of an object is in the rest. So this is the second slide, that is Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum is directly proportional to the force applied in the direction of force. न्यूटन सेकेंड लॉ में कहता है, ये इसकी स्टेटमेंट है, ही स्टेटेड दैट द रेट ऑफ चेंज ऑफ लीनियर मोमेंटम of a body is directly proportional to the force on the body, and this change in momentum takes place in the direction of the applied force. न्यूटन आपको सेकेंड लॉ में कहता है जो फोर्स होता है, फोर्स इज़ डायरेक्टली प्रोपोर्शनल टू द चेंज इन मोमेंटम बाय टाइम. फोर्स जो होता है वो डायरेक्टली प्रोपोर्शनल होता है रेट ऑफ चेंज ऑफ लीनियर मोमेंटम. फॉर एग्जांपल, व्हेन एक्सेलरेशन इज अप्लाइड on a moving vehicle, the momentum of the vehicle increases and the increases in the direction of motion because the force is being applied in the direction of motion. On the other hand, when brake is applied, जब आप ब्रेक मारते हो तो वेलोसिटी क्या हो जाती है, वेलोसिटी डिक्रीज हो जाती है. On the other hand, when brake is applied on a moving vehicle, the momentum of the vehicle decreases. तो वेलोसिटी डिक्रीज़ हुई तो मोमेंटम भी आपका डिक्रीज़ हो गया, एंड द डिक्रीज़ इज़ इन द ऑपोजिट डायरेक्शन ऑफ मोशन बिकॉज द फोर्स इज़ बीइंग अप्लाइड इन द ऑपोजिट डायरेक्शन ऑफ मोशन. दिस इज़ द एग्जांपल ऑफ न्यूटन सेकंड लॉ ऑफ मोशन. सो नेक्स्ट इज़ द मैथमेटिकल फॉर्मुलेशन ऑफ न्यूटन सेकंड लॉ. अब न्यूटन सेकेंड लॉ का मैथमेटिकल फॉर्मेशन क्या है, हमें इसके लिए एक इक्वेशन आनी चाहिए, दैट इज़ एफ इज़ इक्वल टू एम ए. तो अब हम कैसे करेंगे, हम एक ऑब्जेक्ट लेंगे जिसका मास होगा m. लेट मास ऑफ एन ऑब्जेक्ट इज़ m. लेट द वेलोसिटी ऑफ एन ऑब्जेक्ट चेंजेस फ्रॉम u टू v. अब आपके पास एक ऑब्जेक्ट है, आप उस पर फोर्स अप्लाई कर रहे हो. द ऑब्जेक्ट चेंज इट्स वेलोसिटी फ्रॉम इनिशियल टू द फाइनल. The initial velocity of the object is u and the final velocity of the object is v. पहले आपके ऑब्जेक्ट की वेलोसिटी थी u, फिर आपकी ऑब्जेक्ट की वेलोसिटी बनी v. We know that momentum is equal to mass into velocity. Momentum of the object at its initial velocity u is equal to mv, and momentum of the object at its final velocity v is equal to mv. So the change in momentum mv minus mu, final minus initial. So rate of change of momentum mv minus mu divided by t. So according to Newton's second law of motion, force is directly proportional to the rate of change of momentum. Force is directly proportional to rate of change of momentum. So F is directly proportional mv minus mu divided by t. F is directly proportional ma, because v minus u by t, it is equal to acceleration. So next equation, F is equal to kma. K is the constant of proportionality. Proportionality को ख़त्म करेंगे हम, हम वहाँ पे एक कांस्टेंट लगाएंगे. इफ़ k इज़ इक्वल टू 1, अगर हम k को 1 के बराबर रखेंगे तो आपकी इक्वेशन आएगी F इज़ इक्वल टू ma. सो फोर्स इज़ इक्वल टू मास इनटू acceleration. So Newton's second law of motion gives the relationship between force, mass and acceleration of an object. So these are the applications of Newton's second law of motion. SI unit of force. Force is equal to mass into acceleration. The SI unit of mass is kilogram and the SI unit of acceleration is meter per second square, and the SI unit of force is Newton. So 1 Newton is equal to 1 kilogram meter per second square. From the above relation, it is clear that acceleration increases with increase in force. Acceleration decreases with the increase in mass. And the next slide is Newton's third law of motion. Newton's third law of motion states that there is always reaction for every action in opposite direction and of equal magnitude. He stated that to every action there is an equal and opposite reaction. Action and reaction act simultaneously. They act on different bodies. It means whenever two bodies interact with each other, they exert equal and opposite force on each other. One force is action and the another is reaction. Action and reaction act on two different bodies interacting with each other. For example, I am applying a force that is F1 and my force is 40 Newton, and you are also applying a force but in opposite direction. Your force is also 40 Newton, but that is in opposite side. We are interacting with each other. Your force is 40, my force is also 40, so but in opposite direction. For example, my force is F1, your force is F2, so F1 is equal to minus F2, because opposite direction में साइन कौन सा आता है, माइनस. So force is action and reaction. Forces never act on the same body, they act on the different bodies. जो ये action and reaction है, ये हमेशा different bodies पे act होता है. If they act on the same body, the resultant force on the body will be zero. That is, the body will be in equilibrium. अगर ये दो सेम बॉडीज़ पे एक्ट करेंगे तो वहाँ पे जो उनका रिजल्टेंट फोर्स है वो क्या बनेगा, ज़ीरो बनेगा. Action and reaction forces are equal in magnitude but opposite in direction. Action and reaction में क्या होता है, मैग्नीट्यूड बराबर होता है, साइज बराबर, वैल्यू बराबर होता है, लेकिन क्या होता है, ऑपोजिट डायरेक्शन में होता है. Action and reaction forces act along the line joining the center of two bodies. So these are the explanation of Newton's third law of motion. Applications of Newton's third law of motion: walking of a person, recoil of gun, propulsion of a boat in forward direction. So now we have some solved numericals here. Calculate the force required to impact to a car a velocity of 30 meter per second in 10 seconds. The mass of the car is 1500 kilogram. First of all, you have to find the force. That means F आपको निकालना है. A velocity of 30 meter per second in 10 seconds. आपकी बॉडी जो है इनिशियली वो ज़ीरो पे है और उस बॉडी ने जो वेलोसिटी गेन की है दैट इज़ 30 मीटर पर सेकेंड एंड योर टाइम इज़ 10 सेकेंड्स. सो फर्स्ट ऑफ ऑल फोर्स निकालने से पहले हम एक्सेलरेशन को निकालेंगे बिकॉज फोर्स में आपको एक्सेलरेशन की ज़रूरत पड़ेगी. देन we will use the equation, first equation of motion, that is v is equal to u plus at. V you have a 30, you have a 0, acceleration you don't know, and time you have a 10. So acceleration is equal to 3 meter per second square. Now F is equal to ma according to Newton's second law of motion. M is 1500, a is 3, so F is equal to 4500 Newton. The SI unit of force is Newton. Second numerical, you have a cricket ball of mass 70 grams moving with a velocity of 0.5 meter per second is stopped by a player in 0.5 second. What is the force applied by the player to stop the ball? Here the mass is 70 grams. You have to change gram in kilograms first. And your initial velocity is 0.5 meter per second and your final velocity is 0 because with a velocity of 0.5 मीटर पर सेकेंड इज स्टॉप्ड बाय अ प्लेयर. जब भी स्टॉप होता है तो वेलोसिटी क्या बनेगी, ज़ीरो, एंड टाइम इज इक्वल टू 0.5 सेकेंड. सो वी हैव अ इक्वेशन दैट एफ इज इक्वल टू एम ए के बदले हम लिख देंगे v माइनस यू डिवाइड बाई टी बिकॉज एक्सेलरेशन इज इक्वल टू चेंज इन वेलोसिटी बाई टाइम. सो f इज इक्वल टू, वी विल पुट द वैल्यूज एंड वी विल गेट द answer. F is equal to minus 0.07 Newton. And your third is, what will be acceleration of a body of mass 5 kg if a force of 200 Newton is applied to it? Here mass is 5 kg, force is 200 Newton. According to Newton's second law of motion, F is equal to ma. We will rearrange the equation. A is equal to F by m because we will find we have to find acceleration. A is equal to F by m. F you have a 200 and mass you have a 5. Then it is 40 meter per second square. So your acceleration is 40 meter per second square. A bullet of mass 10 gram is fired from a rifle. The bullet takes 0.003 seconds to move through its barrel and leaves with a velocity of 300 meter per second. What is the force exerted on the bullet by the rifle? Here your mass is 10 grams. You have to change gram in kilograms first, and your final velocity is, that is 300 meter per second. And your time is 0.003 and F you have to find. So we have an equation, F is equal to mv minus u divided by t. You have a 0 because initially it's at rest. So you will get the answer, F is equal to 1000 Newton. Next is, what force would be needed to produce an acceleration of 1 meter per second square on a ball of mass 1 kilogram? Here mass is 1 kilogram, acceleration is 1 meter per second square, force you have to find. So according to Newton's second law of motion, F is equal to ma. M is 1, acceleration is 1, then force is 1 Newton. What is the acceleration produced by a force of 5 Newton exerted on an object of mass 10 kilogram? You have a force that is 5 Newton and mass you have a 10 kilogram and acceleration you don't know. So according to Newton's second law of motion, F is equal to ma. F is 5, mass is 10. Then you will get the answer, that is acceleration is equal to 0.5 meter per second square. Next numerical is, how long should a force of 100 Newton act on a body of 200 kilograms so it acquires a velocity of 100 meter per second? So V minus U is 100 meter per second, M is 20 kilogram, force is 100 Newton, so time you don't know. So your equation is F is equal to ma mv minus u divided by t. So the time is 20 seconds. An automobile vehicle has a mass of 1500 kg. What must be the force between the vehicle and road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? Mass is 1500 kg. A is 1.7 meter per second square. That is acceleration, but it's a negative acceleration, that's we call it retardation. So according to Newton's second law of motion, F is equal to ma 1500 into minus 1.7, that is minus 2550 Newton. The force between vehicle and road is minus 2550 Newton. Next is, if 1000 Newton force is required to accelerate an object to the rate of 5 meter per second square, what will be the weight of the object? According to the equation, acceleration is 5 meter per second square, force is 1000 Newton. So mass you don't know, F is equal to ma. 1000 is equal to m into 5 meter per second square. M is equal to 1000 meter 1000 kilogram. A truck starts from rest and rolls down a hill with constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Find the force acting on it if its mass is 7 metric ton. Your initial velocity is 0 because it starts from rest, and your distance is 400 meter and time is 20 second. Acceleration you don't know. We will use the second equation of motion, that is s is equal to ut plus 1 by 2 at square. S you have a here, that is 400. U initially at rest, that is 0, that means 0 into t, that is 0, plus a into t square. Then you will get the answer that a is equal to 2 meter per second square. Then acceleration is equal to 2 meter per second square. Mass is 7 metric ton, that is 7000 kilogram. So F is equal to ma 7000 into 2. F is equal to 14,000 Newton. Thanks for watching.